All right, so in our last video, we talked about combining like terms in order to simplify algebraic expressions. In this video, we're going to talk about the distributive property. And just think of the word distributive like distribute, which is exactly what we're going to do. And when we distribute something, like if I say, here's a stack of papers, distribute them evenly, that would mean pass them out and make sure that each student or every person in the room gets the same amount of paper. And so that's what we're going to use when we do the distributive property. So we're going to make sure that we take our number in front, our coefficient to the entire expression, and we're going to distribute it equally. Now, remember that saying that I have, like, anytime a number or parentheses are touching, I call it kissing. And so here we have the 9 kissing the parentheses, which means kissing leads to multiplication. And so we're going to multiply that through. And so I'm going to take 9 times both terms inside of my parentheses. Or if there's multiple terms, more than 2 terms in the parentheses, we're going to multiply it through all of them. So what this means is we're going to take 9 times 6, and we're going to minus 9 times 5n. And so we're distributing that 9 evenly to both terms inside the parentheses. So then 9 times 6 is 54, minus 9 times 5 is 45. So we're going to take the 9 times the coefficient, and then we keep the variable. And then I look at this, and this is a constant, and this is a variable term, right? Or a term with a variable. And they don't match. They are not like terms. And so that's our final answer. 54 minus 45n, or the other way to write it is a negative 45n plus 54. Either one of those, both, they both represent the same thing. And so that's how we do the distributive property. We just equally multiply to all the terms inside our parentheses. After we do the after we distribute, then we check to see if we need to combine like terms. So here's our next one. The 6k is off to the side with a plus between. That just means I'm going to do 6k plus. And just because we're working with algebraic expressions does not mean we totally drop order of operations. Remember, we talked about how multiplication happens before any adding or subtracting. And so that means we need to take care of distributing this 4 to the 9 and the k. Now keep in mind that k has a coefficient of 1. And so I'm going to take 4 times 9, which is 36. And then 4 times 1, which is 4. And since the 1 has a k, we put a k next to it. Now from here, so that was the first step. First step is to distribute. And the second step is to combine like terms. Which from here on out, if I talk about combining like terms, you'll see me write it as CLT, combine like terms. All right, so my like terms, I have k's, right? 6k and 4k. So we're going to do 6 plus 4, which is 10. So we have 10k plus, and then 36 is the only constant term, so it just stays 36. So we end up with 10k plus 36, and that is our final answer for that one. All right, next one. Here we have 2 sets of parentheses. So we're going to distribute twice. So we're going to take negative 6 times p. Remember, there's a 1, an invisible 1 in front of that p. So negative 6 times 1 is negative 6, and we keep the p with it. So we have negative 6p, and then we're going to take that negative 6 times 8. And so negative 6 times 8, negative times a positive is a negative. So we're going to end up with a negative 48. And now we're going to do 9 times 9. So it's positive, so it'll be plus 81. And then 9 times 6, which is 54. And then that's with a p because it's 6p, so 54 p. So that's our distributive property. We've done the distributive property, right? Distributive. And so our last step is to combine like terms. Now, if it helps, rewrite it, especially when we start getting into negatives joining what we're doing. And so here we have negative 6p plus 54p. And then we have negative 48 plus 81. Now, when we look at this in combining, our integer rules have not changed. We have different signs, right? Negative, positive, which means we need to subtract and keep the sign of the bigger. So the 54 is the bigger number, which means our answer is, the answer we get when we subtract is going to be positive. So then I'm going to do 54 minus 6, and I end up with 48. So we have 48p, don't drop your variable. And then I look at my next one, and I have a negative 48 with a positive 81. Again, different signs, which means we're going to subtract and keep the sign of the bigger number. Bigger number is 81, so it will be a plus. And then we're going to do 81 minus 48. Type that into the calculator, and I get 33. So we have 48p plus 33. Now, again, you don't have to rewrite as one of your steps, but if it helps you visualize the signs and make sure that you're doing your subtraction correctly or your integer rules correctly, I highly suggest writing it out and changing order. Remember that the sign in front of your number is the value of that number. So here we had negative 6p minus 48. This became a negative 48. So just kind of keep that in mind. And so that one was just a little bit more intense, more distributing, and then a little bit more to combine. All right, now here's our last one. You may look at it and go, well, that's much easier than what we just did. What you may not have noticed is we have a variable on the outside. And so we're going to multiply that in. And so we're going to distribute. We're going to take the 7. We're going to take the coefficient times our number. So 7 times 1 is 7. And then because it's 1, the a just goes with it, right? So we have 7 times 1, or 7a times 1 is 7a. Then we're going to take the 7a times and this is a minus, so this is going to be a minus. So 7 times 6, which is 42. And now this is where we have to be careful because we're going to take a times a. And so remember, when we take something times itself, that we write repeated multiplication as an exponent. So a times a is a squared. And so we're going to end up with 42a squared. Now what you may be tempted to do here is they both have the same variable. And so you may say, okay, so from here I'm going to combine. And I'm going to tell you, don't! And you can't combine because this one is an a with no exponent, and this one is an a with an exponent of 2. And so they're not like terms. Just because they have the same variable does not mean that they are like terms. Remember, they have to have the same variable and they have to have the same exponent. And right here, we don't have the same exponent. And so our final answer is 7a minus 42a squared, or you could write it as negative 42a squared plus 7a. Either one of those gets you, they're the same thing. But again, you cannot combine, different exponents. Not when we are adding or subtracting. They don't combine. All right, that is all for our distributive property and our total, in total, our combining like terms and our simplifying algebraic expressions. So after this, we're going to start solving equations. I'll see you in the next video.